dl is similar to that. So therefore I can write it as dB is equal to mu naught upon 4 pi into I dl upon a square. But its direction of this magnetic field, its direction along PM, but its direction is along you can say that PN. So first step, so you got that first step, because of current flowing through the diametrically opposite element, how much current is going to, how much magnetic field produced at this point, so you have to find out. So in order to find the magnetic field at the point P, what you have to do that, see, so as I said it separately, you got it expression for the magnetic field at this point because of this. Similarly, magnetic field at this point because of this, you got it. You see. Now what you have to do that, you see that this magnetic field, PM magnetic field, it will be act in this direction. It has got magnitude is this much and direction is this. So according to the resolution of vectors, this is a vector, it is resolved into two components. So rectangular component. One is going to acting along the x-axis. This is an x-axis, is it? So what is an expression for this? So you see that. See now, what is the magnitude of magnetic field? Because of current passing through the AB having length dl, what is the magnitude of magnetic field? This will going to act along the PM direction. This it is in a vector. It is resolved into two components. PM is resolved into two components, rectangular component. One is going to acting on the axis in the form of dB sin alpha. Another will go to acting in the form dB cos alpha, as you are already familiar that vectors, is it? So this is in a what alpha, is it? So therefore, as I written that, so that is dB sin alpha and dB cos alpha. These are the rectangular component of vector PM. This is a single vector which is resolved or splitted into two or more vectors, which is known as the resolution of vectors. You see. So this is a dB sin alpha which is acting along the what PM direction, and dB cos alpha which is acting along the PY direction. You see. Similarly, this current element, it also produces the magnetic field at the point P, but its direction is opposite to it in the form of PM. So therefore, so once again you have to, this Pn is resolved into two components. That is, so this will be because of current passing through this AB having length dl. That is once again that is dB sin alpha, and this along y dash x, that is dB cos alpha. It is acting in the downward direction. You see that from this figure, what one important vertical component, they are going to cancel each other. These are the vertical components. These are the horizontal components. And watching and observing this figure, what we will find it is the magnetic field along the axis, along the x-axis, that will going to what add up, because both will going to acting in the same direction. dB sin alpha will going to act along px. So similarly, because of this current element, it is also acting dB sin alpha in the px direction. Both the directions, I mean that both the components, they are acting along the what x-axis. So therefore, the magnetic field which is acting along the axis, that will going to add up, whereas the magnetic field which is perpendicular to the x-axis, that will going to cancel. Why that is going to cancel? Because magnitude of these two fields are equal and opposite. See, this field is going to acting in the upward direction, this field is going to acting in the downward direction, both having same magnitude, but the directions are opposite each other. If it is the case, the magnetic field along the vertical component is going to cancel. So only when you are passing current through the diametrically opposite current element, what is the net magnetic field at the point P is dB sin alpha, and this dB, I mean that sum of the magnetic field due to AB and sum of the magnetic field due to A dash B dash, that is you have to sum of the magnetic field due to AB and A dash B dash, that is nothing but the net magnetic field net magnetic field at P due to diametrically opposite elements, that is 2 times of dB sin 2 times of dB sin alpha. This is a magnetic field along the x-axis or dB sin alpha because of this current element. So because of this current element A dash B dash, it is acting dB sin alpha. Both the magnetic field, they will going to act along the axis of the circular coil or along the axis px. So 2 times of dB sin alpha. You can call that this is the equation 1. This we can call that equation 1. This we can call the equation 2. So now from equation 1 you have to substitute that. So from equation 1 you have to substitute from equation 1. So I will rub it here from equation 1. So you see that 2 times of dB is nothing but the, as you are already familiar that, so that is mu naught times upon 4 pi into ideal sin alpha upon A square. So this expression, it is what? Magnetic field at the point P due to diametrically, net magnetic field at point P due to diametrically opposite element this. So in this, as you know, that dB is nothing but the from equation 1. From equation 1, you see, from equation. So now from the figure, what you have to do that? So you have to find an expression for the sin alpha. From the figure, so you see that this is an opposite side, this is an what? Hypotenuse. From the figure, sin alpha is equal to that is opposite side R upon A. So now what you have to do that in place of sin alpha, we are going to substitute that R upon A. So on doing so, 2 times of mu naught upon 4 pi into ideal sin alpha value is nothing but the R upon A divided by A square. So now this you can club. If you club it, this will become A cube. Otherwise you can leave it is. Now the question is that in this what are the variables? Just this is an expression for the magnetic field due to diametrically opposite element. Only this because of these two current element in which I ampere of current is flowing. If it is the case, how much magnetic field is going to act along the axis of the circular coil. So, but this circular coil, if you imagine that this whole circular coil, if it is made up of such diametrically opposite element, if it is the case, then what are the variables here? That small portion of the conductor length that will going to vary. So, so therefore, you have to extend, that is radius, and this all radius and a, this all things will go into constant. Current is also constant. What is the variable? This dl will go into only vary. So that means that magnetic field at point P due to one turn of the coil. So next step, you have to find the magnetic field at P due to one turn of the coil. So this will become what? dB is equal to 2 times of mu naught upon 4 pi into I upon A square into R upon A summation dl. So you see that here, what is the expression for the, see this one turn of the coil, if it is made up of such diametrically opposite element, but summation dl value, summation dl, which is equal to the circumference of the circular coil, which is equal to 2 pi r. Since you are considered diametrically opposite element, so therefore you have to divide by 2. If you consider only only one current element, you can do by two methods. So you can consider diametrically opposite element, or else you consider only one current element, and because of one current element, how much magnetic field is going to produce here, this is you have to find. So then while coming to the, if you imagine that this circular coil is made up of such current element, if it is the case, summation dl will become 2 pi r only. So if you consider that this circular coil is made up of such diametrically opposite element, in this case, so exactly it will become semicircle. So therefore it will be divided by 2. So that means that summation dl is equal to, that is nothing but the what? Pi r. So in place of summation dl, I can write it is, that is dB is equal to, dB is equal to 2 times of mu naught upon 4 pi I r a square a into, what is that? Summation dl, that is nothing but the pi r, right? So you have to rearrange this expression so that we'll get so that is dB is equal to mu naught upon 4 pi, this 2 is taken to inside, that is 2 pi I r square, 2 pi I r square. On simplifying this, so you get it, numerator is like this. So denominator will be a square into a. So you see that once again you have to consider that this triangle, right angle triangle, from the Pythagoras theorem you can find the what is a. So from Pythagoras theorem, So what is that? A square, hypotenuse square, is equal to sum of x square and r square. X square, r square. Or you can say that A is equal to under root of x square plus r square. Root power is, as you know, that is x square plus r square, which is nothing but the half. So here in the denominator, if you plug these powers, that will become a cube. So a cube is equivalent to a square into a. So what is the a square expression for a square? So expression you are already familiar, right? For the figure, a square is nothing but the sum of r square plus x square. So therefore, I can write it as a square is nothing but the r square plus x square into r square plus x square, its power is half. So these two terms bases are same, the powers are equal to, whenever the bases are same, you can add the powers. On doing so, that is a cube equivalent to r square plus x square to the power 3 by 2. This power, you say that 1, this power half, 1 plus half, which is equal to 3 by 2, that is 1 and a half. So therefore its total power is, that is r square plus x square to the power 3 by 2. Now this expression we can rewrite, that is, this expression can be rewrite. So dB is equal to mu naught upon 4 pi into 2 pi times 2 pi times I r square upon x square plus r square to the power 3 by 2. As I said that this expression hold good to evaluate because of current is flowing through the one turn of the coil. So if you consider only one turn, so if it is the case, with this expression you can find the strength of magnetic field at the point P. If suppose, as I said, that we are consider that R is a mean radius. Mean means there are n number of, if for n number of turns, magnetic field at point P, field at P due to n turns, that is just magnetic field is directly proportional to number of turns. As the number of turns increases, magnetic field is also increases. As number of turns decreases, magnetic field at point P is also decreases. That means that magnetic field is directly proportional to the number of turns in the coil. So this we can write it is dB is equal to mu naught upon 4 pi into 2 pi times n I r square upon x square plus r square to the power 3 by 2 Tesla. So this is an expression with which you can find the magnitude of magnetic field at the point P due to n turns of the coil. See, this expression, it looks quite lengthy. Only you have to three step derivation that. In first step, you have to apply the Laplace law for one current element. You have to find an expression from the Laplace law. You have to find an expression for the dB. Similarly, another current element, diametrically opposite current element consider, you will get the same magnetic field, but direction of magnetic field they will going to opposite to each other because the current direction is going to change in the circular coil. Now second, after that this is resolved into two components. One is acting along the dV sin alpha, acting along the x-axis, dV cos alpha, which is acting along the positive y-axis. Because of current passing through this, that magnetic field is going to acting along the Pn. It is resolved into two components. It is dV sin alpha along the y-axis, that is dV cos alpha. So now these two fields is going to add up. The net field due to diametrically opposite element 2 dB sin alpha. This is about the second step. Now as you are familiar that from equation 1 by applying Laplace law, that value, that expression you have to substitute in that expression 2 dB sin alpha. From the figure you have to substitute the sin alpha value. After that, what is that? You have to find the summation dl, because all things are constant in this, only summation dl is going to vary. So that is circumference of the circular coil. Summation dl nothing but the circumference of the circular coil. Since you are considering the diametrically opposite element, this 2 cancel. So summation dl value which is equivalent to the pi r. Therefore you have substituted the summation dl in place of summation dl, that is pi r. So on rearranging all these things, finally you will get the magnetic field due to one turn of the coil. Lastly, magnetic field due to n number of turns, that is magnetic field is directly proportional to number of turns. As the number of turns increases, magnetic field at the point P is also increases. With this expression, we can find how many number of turns, irrespective of number of turns, we can find the magnetic field at a point on the axis of the circular coil carrying current. So I want to conclude here.